Chapter 36, Image Formation. So we are going to study the part that is related to lenses or image formation by lenses. So let's introduce you to lenses. What are lenses? Usually, lenses are used to either converge or diverge a beam. You can see to the right two figures. The upper figure is a convergent lens. It is used to converge light. So as you can see, when light strikes this lens, it converges. The rays of light become closer to each other. So we say that this is a convergent lens. While the figure below represents a divergent lens. What is a divergent lens? A divergent lens means that when light, a parallel light, strikes the lens, it will emerge away from each other. It means that it is going to diverge. So this is a lens. Can we make a comparison between a lens and a diopter? We have studied in the previous chapter a system of diopters. كان عندنا, for example, air, glass, then air. So it looks similar to a lens. They are similar in some ways, okay, in certain ways. But when we use the formulas of diopters, the distance between the two spherical surfaces is large, in comparison with thin lenses. So there's a difference between thin lenses and treating the problem as a system of diopters. في فرق بالحل بين الاثنين. هيدا الفرق هلا رح نشوف انا كيف انا بعتبر انه انا عندي لينس او انا عندي بشتغل كدايوبترز. We will see. Anyway, when you see the problem, you will directly figure out that this is a lens problem and this is a diopter problem. Because in the lens problem, we don't care for the distance between the two spherical surfaces. I don't care because the formulas of a thin lens are independent of the distance between S1 and S2 as in the case of diopters. So الحل رح يكون مختلف واصلا الجيفن بكل السؤال بيكون مختلف. So you can directly figure out this is a diopter problem, no, this is a lens problem. Now, what happens when a light strikes a lens? When light strikes a lens, it will refract on both surfaces. يعني على أول surface we have refraction. On the second surface we have refraction, and we have the final emergent ray. هلا our main problem here دايما شغلتنا نحن انه يكون عندنا object and we try to search for the image of this object when the light crosses this lens. إذا كانت convergent أو إذا كانت divergent. So this is, as I have said, this is a convergent lens and this is a divergent lens. The fourth note says most lenses are symmetrical about a line that passes through the center of lenses and connects centers of curvatures of two surfaces of the lens. This axis is called the principal axis of lenses. So let me explain things in a different way. You remember from diopters, I know that we used to determine the position of the center of the spherical surface. يعني إذا أنا عندي هيدا surface 1, so we can say that C1 is the center of this spherical surface 1. And if this is the spherical surface 2, then C2 is the, I will write like this. So this is C2. It is the center of the spherical surface 2. So the line joining C1 and C2, this is the line joining C1 and C2. This is called the principal axis or the optical axis. So we have explained this also in diopters, principal axis or optical axis. It has the same notation. So when we were treating diopters, we used to say that this is here. So this is surface 1. So this is S1. And we used to say here that this is S2. So these are the points of intersection between the principal axis and the two surfaces 1 and 2. What is the principal axis? It's simply a line joining C1 and C2. So let's take a look on the second one. So I will say this is surface 1 and this is surface 2. Okay, so where's C1 and C2? C1 is the center of the circle of the spherical surface 1, and C2 is the center of the spherical surface 2. So it's something like this. So if I join C1 and C2, I will get, I will get the principal axis. I can call this point here S1 and I can call this point here as 2. It's the same as we have used in diopters. So this is C1 and C2. This is the principal axis or the optical axis. The important information he's giving me here that the lenses are symmetrical about this line. What does he mean by the lenses are symmetrical? He means that if we have a lens and we are going to use this lens, if we use it from the right side or from the left side, it will give me the same image all the time. This is not the same for diopters. يعني إذا أنا فيكم you can try it. Okay, you can go and try it. If you have a diopter problem, إذا نحن بنقلب الدايوبتر يعني بنخلي السيرفس 2 بنخليه قدام والسيرفس 1 بنحطه ورا، بنقلب اتجاه الدايوبتر وبنخلي نفس الايمج يعني نفس المطرح بعد الايمج مطرحها بذاتها. The position of the image will vary. بيتغير موقع الايمج. بينما باللينسز اذا انا بقلب السيرفسز يعني محل ال2 بصير 1 ومحل ال1 بصير 2. Okay, the position of the image will not vary. بمعنى آخر إذا أنا عم بحكيكم بطريقة عامة، أنا اللينس العادي فيني استعملها يمين شمال، ما فيها إشكال أبداً. I can use it in the way I like. Okay, so there is no problem in using the thin lens. بينما بالthick lens, if I invert it or if I change its direction, the position of the image will vary for the object. This is the difference between diopters and thin lenses. Let's start with converging lenses, and كمان same definition as in diopters. We're going to identify the image focus. So what is the image focus? For a convergent or for a divergent lens, same definition but different results. So let's start with a convergent lens or a converging lens, and let's start finding the image focus. By definition, the image focus is the point where the ray meets if it strikes the converging lens parallel to the principal axis. So you can see here, the light is coming parallel. It will converge. It will meet in a single point. This is F prime, called the image. It's called the image focus. Okay, so by definition, نحن بنسمي المسافة من نص اللينس, I will call it O, من ال O لعند ال F prime, this is called the focal length. So OF prime is called the focal length. I will call it F. You can see that in the case of a converging lens, the image focus is real. يعني لما يلتقوا حقيقة الريز، لما يعملوا convergence ويلتقوا حقيقة, so the image is real. ودايما موقع الإيمج بيجي بعد اللينس مش قبل اللينس. So a converging lens makes a beam parallel to the principal axis refract and pass through one point called image, focal point F prime. As I have said, light comes parallel, meets in the image focus or focal point F prime. This F prime is real for a converging lens because in reality the rays of light will meet. The distance OF prime, O هي center of the or middle of the lens, is called the focal length of the lens. This is the focal length of the lens. Now let's define again the object focus. What is the object focus? The object focus is a point. If I place an object in that point and the light is emitted by this object, it will cross the lens and it will leave the lens parallel to the principal axis. So this is the object focus. Object focus. هي بعكس الimage focus. So for the light to emerge out of a converging lens as parallel beam, it must be emitted from a point called the object focal point of the lens. Same definition as diopters, nothing different. So كمان the distance from F to O is called the focal length. So up till now we can see that FO is equal to F, and OF prime is also equal to F, and both focal lengths are equal. يعني حتى ال FO equals FO it's equal to OF prime because simply the lens is symmetrical. يعني هي ما عندها يمين وشمال من جهتين نفس الشيء. So, okay, so FO equals OF prime equals to F, and F is positive. While F is positive because my object focus is real and my image focus is also real for a converging lens. So there is no problem. This is my converging lens. This is my object focus F, and this is my image focus F prime. This is O. So this, by definition, FO اللي هي هيدا positive sense. Don't forget this is the positive sense. So this is FO. It's positive. So this is the image is real. OF prime is positive. So OF prime is positive. The image is real. So FO equals OF prime equals F, which is positive. Okay, this is for a converging lens. So again, we will say that the distance between F and O is equal to the distance between O and F prime. The image focus is real. The object focus is real. This is for a converging lens. Now let's do the same for a diverging lens. Let's see the position of the image focus and object focus. Here in this slide, I have only drawn the image focus, but anyway, the object focus is symmetrical to the image focus with respect to O. Here I have drawn the image focus. So what happens? The light, شو تعريف أول شيء الimage focus? تعريف الimage focus, if the light is going to strike the lens parallel to the principal axis and it will diverge, the rays will not meet. So if I extend them, they will meet. يعني ما بيلتقوا بالحقيقة. الاكستنشن تاعهم هو اللي بيلتقى. So مثل ما شايفين, my rays 1, 2, and 3, they refract twice. And again, they do not meet. But if I extend them, they will meet at a point F prime. First, ال F prime هي اسمها الimage focus. ال F prime is a virtual image focus. ليه؟ لأنه simply هي مطرح الإيمج هو ورا اللينس منه قبل اللينس. أنا عندي هون الإيمج إجا قبل اللينس. ثالثاً ليكون real image لازم اللايت بحد ذاته هو اللي يعمل intersection. أنا اللايت هون ما عمل intersection. الإكستنشن تاعه هو اللي عمل intersection. So this is a virtual image focus. Remember that OF prime is the position of the image اللي هي من عند O. This is O, the center of the lens. So OF prime in my case here is negative. Why? Because F prime is virtual. So OF prime is negative. And in this case, by definition, احنا كنا قايلين إنه ال OF prime هي عبارة عن ال focal length. So we can say that in the case of a diverging lens, the focal length is negative. Okay, so the focal length is negative in the case of a diverging lens. أنا ماني راسمة هون figure, but anyway, so لازم يكون ال object هون. So this is F. Why? Because F is symmetrical to F prime with respect to O. هيدا هو ال object focus. This is my object focus. Okay, so what do we have to keep in mind? Again, but just let me write it. So FO equals OF prime equals F, which is negative. So you can see that FO opposite to the chosen positive sense, OF prime opposite to the chosen positive sense, they are both negative. Virtual image, virtual object, F negative. This is for a diverging lens. So what do we have to keep in mind? الاشياء اللي لازم نحن نتذكرها. أول شغلة بتعريف الفوكال length F. It's always defined as FO equals OF prime. It can be positive or negative. Okay? For a converging lens, it's positive. For a diverging lens, it is negative. تاني شغلة. For a converging lens, F and F prime are real. For a diverging lens, F and F prime are virtual. بيكونوا بعكس مطارحهم الحقيقية بحالة الفيرتشوال، بحالة diverging lens. ثالث شغلة لازم نتذكرها إنه ال F and F prime are symmetrical with respect to all. All the time they are symmetrical. Okay, so these are the things that we have to keep in mind. We have seen in the previous chapter thick lenses. Thick lenses بمعنى آخر system of diopter. When do we treat the system as thick lens and when do we treat it as a thin lens? Simply, when the distance between, so this is a thick lens, this is a diopter, assume we have an air, we have a glass, we have here air again. So this is S1 and this is S2. You know, sorry, this is S2. Okay, so this is C1, assume this is C1, this is C2, the center of the spherical surface. If the distance S1, S2, the distance S1, S2 is greater than R1 and R2, then the radii, the lens is said to be thick. Okay, the lens is thick, and we treat the problem as a system of diopters. Now, if S1, S2 is smaller than the focal length or the focal distance, then we can consider it as a thin lens. What is the difference between them? Simply in the formula used. And in an exercise, it appears clearly that it is a lens or a diopter, because when we introduce the problem, we say that we have lenses or we have a diopter. We differentiate between them. So no need to worry about differentiating between diopters and lenses. But we have to keep in mind that if the distance S1, S2 is large enough, then we just treat the problem as a diopter. If this distance is very, very small compared to the focal distance, then we can go to the thin lens. Now, for thin lenses or thick lenses, we have many different shapes. Okay, different shapes will give us different focal lengths. Okay, but all of them will act the same. All of them will follow the same. When we study a case, we don't draw a lens. We simply use the symbol of a converging and a diverging lens. We will see the symbol right after this slide. So let's start first with converging lenses. Converging lenses, they are called also called convex lenses. They are also called convex. So for a double convex, you can see that we have a spherical shape from both sides. Okay. Plano-convex, we have a side plane and the other is spherical. For a converging meniscus, you can see that we have two spherical surfaces, but you can see that it's different from the double convex. There's a difference in the direction of the spherical surface. So here, if I have, this is, يعني إذا هيدا عندي radius R1, هيدا عنده radius R2. So in this case, we can see that R1 is larger than R2. So once R1 is larger than R2, so in this case, this is a converging lens. To the left, we have a set of 3 diverging lenses, also called concave lenses. A double concave, it has 2 spherical surfaces like this. Plano-concave, one plane and the other spherical. And the last one is a diverging meniscus. It's similar to the converging meniscus, but the difference is that this has a radius R1 and this had radius R2. So here R1 is smaller than R2, like this. So مثل ما شايفين بالdiverging meniscus والconverging meniscus يعني هي اللينس الجهة الجوانية منها إذا عندها الراديوس هي الجهة الجوانية إذا عندها راديوس أصغر بتكون diverging. إذا الجهة الجوانية عندها radius أكبر بتكون converging. Okay, so no need to memorize these, but just take a look on them. Anyway, I will repeat again. هدول lenses, if we use them to the right or to the left, يعني إذا يمين شمال استعملتهم, it doesn't matter because they are thin lenses and I can use them as I like. It will not affect the focal length. ما بيأثر أبداً على focal length تاعولن ولا على answer of my problem. So I can use them as I like. يعني حتى لو هيدي أنا استعملتها هيك للdiverging meniscus، مثلا أنا عندي هيك ما أعرف كيف هيك عندي Okay, so like this. So نفس الشيء كمان بدها diverging، ما خص الاتجاه تاعولها. It will always remain diverging. إذا أنا رسمتها هيك، so هيدي صارت ال R1 هون وهيدي ال R2 هون. You can see that R1 is less than R2. Okay, so this is the difference between a diverging and a converging lens. Okay, now we're not going to go into shapes. We're just going to represent our lens by a simple diagram. Converging lens, you can see that the arrows are inward for a converging lens, and for diverging lens or concave lens, the arrows are outward like this. So we're going to use these representations. Remember, for a converging lens, the focal length is positive. For a diverging lens, the focal length is negative. Okay, this is for a converging and a diverging lens. Now, let's start talking about the image. All our problem or all our aim in this lesson is to find a formula, and this formula helps us to find the image of a certain object. هيدا كل شغلنا بهيدا الدرس. Everything else is just help in order to understand the lesson. But our aim is to find the formula and to apply. And up till now, no need to memorize anything, just ideas and just understand them. So formation of images by thin lenses. Before talking about the image, we just consider some terms or just remember some terms. So a principal axis, what is the principal axis? It's this line. It is the principal axis or the optical axis. Remember, the principal line, it is the line that joins the center of the spherical surfaces. Okay, so C1 and C2 are not drawn here, but it's the line joining them, principal axis. Where is the optical center? It is O. So in the case of lenses, we don't care for S1 and S2. We only concentrate on O, which is the center of the thin lens, because we consider the lens is thin enough to be represented by a certain point, by a single point O. وهيدي الpoint O, which is at the center of my lens, if a ray passes through this point, it will complete undeviated. So you can see that ray 2, when it crosses point O, it completes undeviated. So this is the optical center of the lens. Again, we have two focal points. The first one, هيدي ال F, نحن عندنا converging lens, so F and F prime are real. F is the object focus, so F is the object focus, it is real. The distance from F to O is equal to F, you can see. F prime is the image focus, and OF prime is also equal to F. So again, FO equals OF prime equals F. It is positive in my case because I have a converging lens. Remember, F and F prime are symmetrical with respect to O. F is called the focal length. Okay, now, if you are interested in drawing the image of a certain object, we now talk geometrically, but we don't usually ask geometrically. We ask only using calculation. So how do we find the image of a certain object? So assume we have this object AB. This is our object AB. O is the optical center. You can see we have drawn the converging lens by simply its diagram. So it's a line with two arrows like this. And how to draw the image? So to draw the image, we simply take two rays coming out of B, and where they meet بيطلع الإيمج للB اللي هي الB prime. So if these two rays meet in reality بيكون عندي real image. If they do not meet and their extension meets, so we have a virtual image. It depends on the case. نحن بحالتنا هون, let's take two lines coming out from B and see where they intersect. رح بلش أول شيء بالline 1. So line 1 goes out of B. You can choose any two lines. All lines coming out from B will meet in B prime. So I can choose any two rays. I choose two special rays. One parallel and the other passing through O. And maybe one passing through the focal point. It depends. So I will start with 1 and 2. We have drawn one parallel to the principal axis. So it will converge. And when it converges, you can see that it passes through F prime. نحن بنعرف بتعريف ال F prime every ray coming parallel to the principal axis will pass through the focal point F prime, will pass through the image focus. So بكون جاي parallel بينزل بالimage focus. So رسمنا أول ray 1. This is the ray 1. Ray 2 passes through O. We know that the ray passing through O will complete undeviated. It completes straight, it does not deviate. So we have drawn 2. The intersection between 1 and 2 is simply B prime. So if we draw B prime, the image of B, we draw it perpendicular to the principal axis and we have A prime and we've got the image. So this is, it's easy to find B prime, the image of B. We can also draw a third line if we like. It's not obligatory, so a third line. And it will also meet in B prime. So I will choose this line passing through the focal point F, the object focus. So this is the object focus. So كلنا بنعرف إنه كل line بيمرق بالobject focus بيظهر parallel. So you can see it is parallel to the principal axis. So it leaves parallel to the principal axis, and hence all the rays will meet in B prime, which is the image of B. And in my case here, I have B prime, a real image. And of course, AB is a real object, for sure. Okay, this is for geometrical finding of the image. Now, we search for an analytical method to find this image. We try to find the formula to memorize, to use, to find the image of a certain object. So if we have the position of the object, can we find its image? So let's see. Let's define certain terms to find the formula. We will define H, which is AB, length of the object. H prime, it's A prime, B prime, the length of the image. We have F equals FO equals O. F prime is the focal length. L, the distance from A to O. So AO, it's the object distance from the lens. OA prime, from here to here, OA prime, it is the image position. So مثل تعريف diopters, AO هي للobject, OA prime هي للimage. So we will see that again, يعني بس احكي بالآخر that F مثل ما اتفقنا can be positive or negative depending is the lens converging or diverging. L can be positive or negative depending on whether the object is real or virtual. Well, L prime كمان can be also positive or negative depending on the image if it is real or virtual. Now we just calculate them, and if they come out to be negative or positive, we just deduce. Okay, so don't worry for drawing virtual images or virtual objects. Now we're just going to find the formula using this figure. In this figure, we have a real object. Everything is real, but the derivation is also valid for a virtual case, for a virtual object, for a diverging lens, for all cases. The derivation is true for all cases, but I'm going to explain it for this particular case. So let's start by doing some geometry. Let's choose this triangle, this small triangle. So you can see in this small triangle that tangent alpha, it's equal to opposite over adjacent. So it's simply H over L. So this is H and this is L. So you can see that from this triangle, tangent alpha equals H over L. Let's choose the second triangle, this one. هيدا التريانجل الثاني. Okay, so tangent alpha is also opposite over adjacent. So it's simply H prime over this distance, which is L prime. So هيدي من هون لهون كلها هي L prime. So this is L prime. Equating tangent alpha with tangent alpha, we will get H over L equals H prime over L prime. So I'm writing here. So just do a certain flip and you will get H over H prime equals L over L prime. This is equation 1. Again, let's use another geometry to find tangent theta. So let me use, okay, let me use this triangle. Okay, again. So tangent theta with this triangle is equal to opposite over adjacent. الopposite هو من هون لهون, which is h. So this is opposite. Where's adjacent? Here is the adjacent. من عند ال O لعند ال F prime, which is F. Okay, so h over F. So tangent alpha will be h over F. لأنه من ال O عند ال F prime is simply F. And the height that I've drawn up, it's AB, which is equal to h. Okay, I will choose another triangle, this one, and I will going also to calculate tangent theta. Tangent theta is equal to h prime over this distance. So this distance, it's simply L prime minus F. Why? لأنه من ال O عند ال A prime هي كلها L prime, position of the image. ومن ال O عند ال F prime هي ال F. So بيبقى عندي من ال F prime عند ال A prime, it is simply L prime minus F. L prime minus F. So I will get tangent theta from the second triangle equals h prime over L prime minus F. So here it is. So I try to equate these two. بحط هاي بتساوي هيدي. Okay, so I get this equation. So now change the shape of the fraction. So this over this and this over this. We will get h over h prime equals f over L prime minus F. This is the second equation. Now from the first equation, I'm going to replace L over L prime with h over h prime. So we will get L over L prime equals f over L prime minus F. Now cross multiply. I've cross multiply both equations, rearrange, divide all the equation again by L prime over F. We will arrive to the formula that we have to memorize, which is 1 over L plus 1 over L prime equals 1 over F. You can see that this formula does not depend on the index of the lens. There is no index. There is no S1, S2. ما في. There is nothing. Okay? There's only certain indications, which are أول شيء L is AO اللي هي position of the object with respect to O اللي هي optical center. L prime, it is OA prime, position of the image. F is simply the focal length. Again, this formula is true for a converging lens, for a diverging lens, for a real object, for a virtual object. It doesn't matter. It's always true. Okay, we can apply it as we like. So it's very easy. It's even easier than that of diopters. After finding the position, أكيد, if we have the object, we can find the image. If we know AO, for example, we can know OA prime. We can know where's A prime, the image position. So إذا عرفنا A prime, we also care for the magnification. يعني إحنا عرفنا وين مطرحها بس ما عرفنا السايز تاعولها. We need to know the size of this image. How to find the size of my image? Using the magnification term. Similar command to previous one in just simply minus L prime over L. So gamma, which is the image size over the object size, equals minus L prime على L. So again, let me go back. You can see from equation 1, let me erase here, erase all. From equation 1 كان عندي ال H prime على H equals L prime على L. The H prime, it's the size of A prime B prime. Well, H, it is the size of AB. He can't L prime على L. Okay, so this is a derivation without signs. But if I'm taking the signs into account, then AB and A prime B prime, and if AB is erect, A prime B prime is inverted. So أنا إذا بدي أكتبهم كجاما, so مع signs, so A prime B prime over A B, it will give me minus L prime على L. This minus sign is simply because the image A prime B prime is inverted with respect to the object. Okay, so we get this formula. We have to memorize it. This is also always true for any lens. Gamma equals minus L prime over L. So again, if we calculate gamma and gamma is positive, it means that the image is erect. And if it is negative, it means that the image is inverted. Inverted means that if the object is upward and the image is downward. أما إذا كان erect, it means if the object is upward, then the image is also upward. Okay, so they have the same orientation, gamma positive. They have different orientations, then gamma is negative. Okay, now if gamma is greater than 1, it means that the size of the object is larger than the size of the image is larger than the size of the object. The image is magnified. If gamma is less than 1, then the size of the image is smaller than the size of the object and the image is diminished. Okay, so this is for that. These equations are true for a converging lens as well as a diverging one. The following sign conventions are used. So I've talked about that. So F is positive for a converging lens, negative for a diverging lens. L positive for a real object, negative for any real one. L هي ما تنسوا ال AO. So L, it's always AO. Okay. L prime is positive for a L prime is OA prime. So L prime is positive, it means we have a real image. L prime is negative, it means we have a virtual image. So دايما الأوبجكت مطرحه قبل اللينس. إذا إجا بعد اللينس الأوبجكت so it's virtual. الإيمج مطرحه ورا اللينس. إذا إجا قبل اللينس بيكون virtual. This is for real and virtual. I will pass rapidly through this to see different cases of for a converging lens, and I will tell you what to keep in mind. But it's good to see it to be able to understand problems easier. Okay. أول شيء, if light is coming from a very far place, يعني L equals infinity, so light will be coming parallel. If it comes parallel, then it will pass in the image focus. Simply, if light is coming parallel, okay, so first information we have to know that if light is coming parallel from a distant place, in this case, L prime, it's equal to F. It will pass in the image focus. Well, we know this information. Second figure. Now, if the object is larger than 2F, يعني أبعد من twice the focal length. الF هي focal length, object focal length, 2F twice the focal length. Okay, so in this case, you can see that the image of my object is formed in between F and 2F, and it is inverted and real. You can see that it's real and inverted or smaller in size. So this is if we are looking at something أبعد من twice the focal length. We will see the figure inverted and smaller in size. Now, if the object is at twice the focal length exactly, الإيمج بتطلع كمان على الفوكال length على twice the focal length exactly, same size, inverted و same size. يعني بيطلع ال A prime B prime equals AB كsize. Okay, they are, but it is inverted, which is similar to the functioning of a photocopier. بتطبع لنا وراء, for example, it uses a lens with twice it uses an object at 2F. Now, if my object is in between 2F and F, F, remember, it's the focal length. 2F is twice the focal length. So in this case, my image will be L prime further than twice the focal length, يعني أكبر من 2F, أبعد من 2F الإيمج, وبتطلع magnified. It is and كمان inverted و real as it appears. Okay, so similar to the working of a projector, because when we project things, we see that we have a larger image. Now, at the focal length, على التحديد, على الفوكال length. If the object is at the focal length نعرف نحن إنه the light will leave parallel. The light will leave parallel. So this is for a for an object at the focal length. Now if the object is in between F and O يعني أصغر من الفوكال length الأوبجكت، بهيدي الحالة أنا كل هدول عندي converging lens بيطلع عندي virtual image. So you can see my image is virtual. There is no meeting of the rays. ما بيلتقوا الريز، الاكستنشن تاعونه بيلتقى وبيطلع الايمج بتطلع قبل اللينس مثل ما شايفين. Its position is not after the lens, it's before the lens. Okay, so what do we have to keep in mind from all of this? The converging lens always gives a real image except between F and O. يعني بكل المطارح في عندي real image ما عدا لما صار الأوبجكت ما بين الأف والأو صار الإيمج فيرتشوال. أوكي، بكل المطارح التانيين كانوا real image. هلا في عندي أنا ما بين مثلا ما بين الانفينيتي والتو اف بتكون الإيمج بتصغر، بتكون الإيمج is diminished. على التو اف على التحديد بتصير الإيمج equal للأوبجكت يعني كسايز، وما بين التو اف والاف بتكون magnified. اوكي، وذاتس ات. This is that we have to keep in mind. بس انه اهم فكره نحن نعرفها من كل هذا اللي انا حكيته انه for an object between F and O يعني اذا كان بهالزون الاوبجكت بيطلع الايمج تاعته virtual. بكل المطارح الثانيه يعني اذا كان كثير قريب على اللينس على الكونفرجينج لينس بيطلع الايمج فيرتشوال. اما بالمطارح الثانيه ابعد من الاف ابعد من الفوكال لينث كل الاوبجكتس بهالزون بيعطوني ريل ايمج. So this is for a converging lens. So I will give you again some examples. So you can see this one. This is a telescope in reality. هيدا بيستعمل converging lens و object beyond 2f which is similar to this case. هيدي. Okay, so هون نحن عم نستعمل converging lens. نحن عم نشوف الشجرة أبعد من twice الفوكال length. So we see the image of a tree inverted and diminished. We look at the figure again, so you can see that the image of the tree is diminished and inverted, and this is a converging lens. So we use هيدا بالحقيقة لما تكون real image اللي هو في بيكون بقلبه سكرين أو شيء حتى أنا أقدر أشوفها. Okay, so this is not a direct transport of image. So this is some sort of telescope. But anyway, this is a real image, and this image is printed on a certain screen in order to allow me to see this image. Okay, inside the telescope. So this is a case where we use a converging lens to see something distant. For distant objects, the image is diminished and inverted. هيدي الحالة اللي أنا حكيت عنها هون. So this is for this case. So this is for seeing a tree. So this is for the tree exercise. Now let's see another exercise. This one. This one also uses a converging lens, and the object is between F and F prime and the lens. So I'm talking about this case. Where is it? Here it is. Between. عم بحكي أنا عن هيدي الحالة. Is an object, so this is for using like something like a magnifier. So لما يكون الأوبجكت قريب كتير على اللينس the image is virtual erect طلعوا erect تبقى erect مثل نفس الدايركشن وmagnified. So let's take a look. طلع. If I'm looking at 7 I'm using a converging lens. The distance is small يعني أنا أكيد ما بين الأف والأو. Okay, الأوبجكت ما بين الأف والأو. الأوبجكت is 7 هو drawing of the 7. Where is the image? You can see that the image is also virtual. شنو virtual image؟ يعني بعدني أنا عم شوف السبعة بعدها على يعني ما حسيتها انتقلت لورا اللينس بعدها قبل اللينس بعدها. So I always see my letter to the other side of the lens. So محل ما الأوبجكت بعده موجود الإيمج. So I only see that it is magnified. وأصلا ما قلب بعده السبعة أنا عم شوفه بنفس الاتجاه يعني ما صار مقلوب inverted. So this case corresponds to the case that I have explained here, that because my object is close to the lens, it is between F and O, between الfocal length وال O. So بهيدي الحالة أنا بشوف virtual image. يعني شو يعني أنا بشوف virtual؟ يعني ما بطبع الإيمج على ما بطبعها على سكرين للإيمج، لا لحتى أشوفها. الإيمج أنا بشوفها، بتطلع بشوف الأوبجكت أو بشوف صورة الأوبجكت اللي هي الإيمج، بشوفها من تاني جهة، ببين لي إنه هيدا هو الأوبجكت أنا. Okay, that's it for virtual. This is a virtual image. So this is a virtual image. This is a converging lens, and this is a virtual image. Okay. So now this one here, this is a real image in reality. بس أنا الreal image حتى أشوفها it needs a screen. Okay. يعني لازم يتجمع الضوء على شيء تحت أقدر أشوفه. So this is some sort of telescope that allows us to see. يعني there's a, يعني a system of lenses that allows me to see the final image. So anyway, don't worry for it. What happens for a diverging lens? What do we have to keep in mind? For a diverging lens, a real object will always give a virtual image. This is the thing that I have to keep in mind. إذا أنا عندي real object, so you can see this is a real object. If I have to find the image, I draw two rays. Ray 1 parallel, it passes through the image focus. So this is the image focus. So هلا أنا رح نعمل diverging بكل الأحوال. So this is if I extend it, it will meet in F prime. الF prime ما تنسوا الF prime بتكون من هاي الجهة بحالة diverging lens. So this is ray 1. Ray 2 passes through O, it completes undeviated. بعمل intersection ما بين ray 1 ray 2 بيطلع عندي أنا الإيمج. So if I intersect them إذا هيدي هي ال B, so this is B prime simply. So هيدي هي ال A وهيدي ال A prime. So you can see that my image is virtual. حتى لو الأوبجكت كان real، في عندي object حقيقي، الإيمج طلعت نفس الجهة تاعت الأوبجكت. So this is a virtual image. So I have to keep just this information in mind, that if I have a real object, my image will always be virtual, erect, and smaller in size. Now take a look at this figure. هون عم نستعمل نحن diverging lens. Diverging lens. So you can see that the image أصغر بالحجم، بعدها erect يعني ما قلبوا الأرقام. Okay. and it is virtual. يعني أنا دايما بشوف المسطرة ورا الإزازة، بشوف المسطرة قدام الإزازة. هيدي هي Okay, so it is a virtual image. So let's go back to the case of a magnifier. So this magnifier here, this is a converging lens. This is a converging lens. هيدي هون هي divergent lens. So the magnifier is not in reality a diverging lens. It is a converging, because a diverging lens for a real object, it gives a smaller image. أنا ما بدي smaller image بالmagnifier. I need a larger image. So we use a converging lens وبقرب اللينس على الأوبجكت، بصير أنا ما بين الF والO، فبتعطيني larger image. Okay, so just to understand things. Now we have arrived to the end of this presentation. The lens maker's formula, I will explain it. So we know that initially my lens is formed of two spherical surfaces with radii R1 and R2. Here I have drawn a converging lens. So it doesn't matter, they can be like this, the radii, it can be like this, it can be like this. So this is R1, this is R1, this is R2, this is R1 here, this is R2. So it depends on my case. R1, R2. Same as diopters, if you remember. This one, R1 is, this is SC, so this is R1 is negative, this is R2 here, it's negative, this is R1 here is negative, R2 is, this is like this, it is positive, This is R1, it is positive. This is R2 is negative. So I will remind you that the R هو SC. So this is S, هيدي S وهيدي C. So هيدا الشكل اللي أنا شايفيته إذا كان الكيرفتشر هيك. So in this case R is positive لأن هذا البوزيتيف سنس تاعولي. وإذا أنا عندي الكيرفتشر بهالطريقة. So this is S وهيدي C. So you can see that SC in this case, this is R equals SC, it is negative. This is SC. Okay. So you can see that R1 and R2 can be positive warnings. So there's a formula that joins the focal length of a lens with the index of the material المصنوعة منها لهيدي اللينس والR1 والR2 that are the radii of my lens. And what's interesting if I invert the lens and I try to find f1 and f2, I will always find the same focal length because the lens is symmetrical with respect to the principal axis. Simply رح يتغيروا الساينز للR1 والR2 إذا أنا بقلب اللينس بيتغير البوزيتيف sense, but at the end I will find the same focal. Suppose that the two surfaces of a lens have different radii of curvature R1 and R2. And index of refraction of the material and between them. So we have glass, plastic, any type of index between them. Lens maker's formula says that 1 على F يعني الواحد على الفوكال length لللens equals n minus 1 لأن هو الإندكس 1 over R1 minus 1 over R2. أوكي يعني أنا هيدا عندي البوزيتيف sense. This is R1. هيدا عندها radius R1 هيدا عندها radius R2. كلكم تعرفوا انه ال R1 is positive ال R2 is negative. كمان شرحتهم ب diopters. So R1 is positive لأنه الكيرفتشر مع ال positive sense. ال R2 is negative لأنه الكيرفتشر للسكند sphere بعكس ال positive sense. So when we substitute them بالفورمولا they must be substituted with their signs. Okay? They must be substituted with their signs to get the correct answer. So you can see that this formula relates the focal length of the lens with the index of refraction R1 and R2, which are the radii of the two surfaces, and it's true for a converging lens and also for a diverging lens. Now, sometimes instead of giving us the focal length of a lens, they give us something called the power or the versions of the lens. Power, the versions. كل ما اللينس كان عندها فوكال لينث أصغر، يعني شو يعني فوكال لينث أصغر؟ يعني الضوء جاي باراليل بيقدر يعمل convergence على مسافة قصيرة. أوكي؟ سو هيدول اثنين لينسز، هيدا بيعمل convergence على مسافة طويلة. سو كل ما تكون الفوكال لينث هيدي الأف. أوكي؟ سو this is F prime. This is F prime. كل ما تكون الفوكال لينث عندي أصغر بتكون الباور أكبر بيقدر يعمل convergence على مسافة قصيرة. So the power of a lens is defined as 1 over F. Well, F هي focal length لللens. So the shorter the focal length of a converging lens, the higher its power and the better is its at converging light. ونفس الشيء بالنسبة للdiverging lens. So P it's equal to 1 over F. هلا هيدي البي ما رح نستعملها بهيدا الدرس، رح نستعملها يعني ما رح نستعملها بهيدا البارت، رح نستعملها أكتر بالاي. سو لما نشتغل بالاي رح نشتغل عليها أكتر ورح أرجع أشرحها مرة تانية للباور. So the power it's equal to 1 over F. أكيد الأف عندها يونت متر، البي عندها يونت دلتا، أحيانا بنسميها V، نحن بنسميها V اللي هي versions. أوكي V or P، يونت للV or P هي دلتا صغيرة اسمها diopter، والF عندها يونت متر. We will talk about them in the second part of the lecture. هيك بنكون خلصنا البارت تاع الlenses. If anyone has a question